All right, 9.6 inscribed angles. So an inscribed angle is an angle where all 3 points lie on the circle. And I think that's the wrong version of lie, but oh well. So if we look at our picture here, I've got a circle and the orange angle is an inscribed angle because its vertex and the other 2 points all sit on the circle. None of them matters about the center of the circle. It's on the edge. We notice that if the angle is x, then the arc is 2x. We could also draw in a central angle, say that this blue point is the center of the circle. This guy here would be 2x. Right? So you could say the inscribed angle is half of its arc, or you could say it's half of its central angle, or you could say that the arc is 2 times the inscribed angle, right? Normally, you need to remember that the inscribed angle is half of its arc. That would be the thing to remember. All right. Number 1, find the measure of the arc or angle indicated. So we're supposed to find this. So I know that if I follow its arms out, it's this whole guy here. I'm going to erase this. So we need to find how big that blue arc is. I know the 74 here, but we don't know the other piece. So I'm just going to start drawing in everything that I know. I know that this whole piece here is going to have to be 77 times 2. So this is 154, and if I subtract 74, I get 80. So this chunk here is 80 degrees. The chunk up there is 74 degrees. I know that all the pieces of the circle, if I go all the way around, it's going to be 360. So what if I call this x? Actually, let's do this. Let's call the angle x, and then this can be 2x. I add them all up, and I should get 360. So I'm going to say, well, 154 plus 80 plus 84 plus 2x is 360. So 154 plus 80 plus 84 is 318. If I subtract, I get 2x is 42, so x is 21. So the angle there is 21 degrees. All right. Some of these problems, there's not going to be a really obvious direction to go, so you just start writing in everything that you can, and then you'll find it halfway through. All right. Number 2, the directions now say solve for x. So the 34x, this thing here, would be 2 times the 34x, so that would be 68x. Now I can take, well, everything in the circle adds up to be 360, so 134 plus 158 plus 68x is 360. So 134 plus 158 gives me 292. I subtract 298 and 68x equals 68 and x equals 1. There we are. Number 3. Now it says find the measure of the arc or angle indicated. So we're going to have to find our x, and then we're going to have to plug back in and get our angle. I'm going to write in what our angle is. It's LVW, so it is this thing there, so that we don't forget what we're looking for. All right, so I'm looking here, and I've got the 70 and the 7x minus 4 are both arcs. The 8x minus 14 is an angle. So what I'm going to do is I'm going to find this chunk there. That's going to be 2 times 8x minus 14. So that's going to be 16x minus 28. Now this is also the arc, and all 3 pieces will make the full circle. So I could say, well, 70 plus 7x minus 4 plus 16x minus 28 is 360. Right? I just had 1, 2, 3 pieces. All right, now I combine like terms and whatnot. 70 minus 4 minus 28 gives me 38. So I took care of that, that, and that. 7x and 16x will give me 7 and 16 is 23. Whenever I take 360 minus 38, I get 322. Dividing by 23, and x is 14. Well, I'll box that in. Now, but that's not the end of the problem. We still need to find the measure of angle LVW, and that is the 8x minus 14. So I'm going to say, well, 8x minus 14, oh, not 8x, 8 times 14 minus 14, well, that's the same thing as 7 times 14. 7 times 14 is 98. 98 degrees. Okay, number 4. Now we have a theorem or a postulate or whatever you want to call it that we need to write down here. This is called an inscribed quadrilateral. Quadrilateral means that it's a 4-sided shape. Inscribed means that it is inside a circle. It means that all 4 points or all 4 vertices lie on the circle. So in an inscribed quadrilateral, opposite angles are supplementary. And that means 180 degrees. So in an inscribed quadrilateral, the opposite angles are supplementary. So the opposite angles here would be like the angle D and angle F would be supplementary. Angle E and angle K would be supplementary. So I could say, well, 2x plus 80 plus 25y equals 180. And then for the green, I can say, well, x plus 79 plus 26y minus 3 is 180. Now what we have here is 2 equations and 2 unknowns. So we're going to have to solve these as a linear system. So for starters, I want to make these a little bit prettier. I'm going to get rid of my constants and put them on the right side and leave my x and y on the left. So the top one will turn into, I'm going to subtract 80, so I'll have 2x plus 25y equals 100. The bottom one will turn into, so I'm going to have 180 minus 79 plus 3 will be 104 on the right. So I took care of that, that, and that. And then I'm going to have x plus 26y. Yeah, x plus 26y. All right, and if we remember from Math 1 material, we now have the decision, do we want to solve by graphing, do we want to solve by elimination, or do we want to solve by substitution? The one that I normally go with is substitution. And so The bottom one, I'm going to solve for x because that's the one with the 1 in front of it. So the bottom one will turn into, what will that turn into? It'll turn into x equals 104 minus 26y. Now I'm going to take this and plug it into the other x. So hopefully you guys have enough space here. I'm sorry if you don't. So I'm going to take both of those and plug them in together. So I'm going to have 2 parentheses 104 minus 26y plus 25y is 100. So 208 minus 52y plus 25y is 100. I'm going to go ahead and subtract my 208. So I've got 100 minus 208 gives me negative 108. And then 25 minus 52 gives me negative 27y. I divide 108 by 27. They're both negative, so they cancel, and I get y is going to be 4. Now I plug back into my x equals equation to get my x equals. So x equals 104 minus 26 times 4. So I'm just going to type that in my calculator. 104 minus 26 times 4 gives me 0. So x equals 0. And what are we actually supposed to find? We're supposed to find x and y. Well, there they are. X is 0, y is 4. All right. Number 5, find the measure of the arc or angle indicated. So we're supposed to find that arc there. How could we go about that? Well, we know this guy here would be 110. He's 110 because we take the 55 times 2. And now if I call this x, then I'd say, well, 102 plus 110 plus x is 360. So solving for x, I say, well, 360 minus 110 minus 102, and x is 148. All right, nice and easy. Number 6. All right, so this is kind of hard to see. The 53, I believe, is talking about that one there. 3x plus 7 is talking about that one there. Well, let's go ahead and draw in their arcs, just so that we can see. 53 times 2 is 106. 106. And that's talking about this guy there. 3x plus 7 is the same, well, the arc for it is 6x plus 14. That's talking about this arc here. Now, the secret to this problem is looking at the diameter there. The diameter splits it up into a semicircle, and we know that the right side of it, or the left side, depending on which one you're looking at, adds up to 180 degrees. So I could say, well, 6x plus 14 plus 106 is 180. So if I solve this, 180 minus 106 minus 14 is 60. So 6x is 60, and x is 10. All right. Number 7, find the measure of the arc or angle indicated. What are we supposed to find? Arc PF. So PF is this. Basing off of this angle, I could say, well, this whole thing is 18x minus 18. Well, 2 parts added up is the whole. So I'm going to say, well, the 6x plus 20 plus 7x plus 17 equals 18x minus 18. 6 and 7 gives me 13x plus 37 is 18x minus 18. I'm going to move my x's to the right to keep the coefficient positive. So 8, 7, 6, 5x, and 37 and 18 gives me 55. So 11 is x. I wasn't really supposed to find 11 though. I was supposed to find that arc over there. So I'm going to plug this guy in. I'll say, well, 6 times 11 plus 20. That's 66 plus 20, 86. And we're talking about degrees. All right, number 8. All right, another inscribed quadrilateral. So again, opposite angles are supplementary. So I could say 47y plus 8 plus x plus 86 is 180. And then going off the orange ones, I could say, well, 54y minus 2 plus 2x plus 74 is 180. I'll try to be more better with my space here. I'll take the top one and pull it down a little bit and try to simplify. So I'm going to have, well, 47y plus x equals, what is that, 90? Is that 94? I'm thinking that's 94. I'm going to type that in because I'm not certain. Yeah, that is 94. The next one's going to be 54y plus 2x is, so 180 minus 74 plus 2 gives me 111. All right, again, I'm going to use substitution. You could use elimination and multiply the top one by -2 if you wanted to. I like substitution more though, so that's what I'm going to do. So the bottom one, whenever I get my x equals, I'll have, well, x equals 94 minus 47y. And this will go inside the other x. So I'll have, well, 54y plus 2, parenthesis, 94 minus 47y is 111. So 54y plus 2 times 94 is going to be 188 minus 94y is 111. So 54 minus 94 gives me -40, -40y. So 111 minus 188 gives me -77. All right, something's off here. All right, I found my mistake. It was up here at the 111. I got the 111 from 180 minus 74 plus 2, and that is not what it's supposed to be. I think it's supposed to be 108, but let me type it in. 180 minus 74 plus 2. That gives me 108. So this 111 there should be a 108, and I'm going to highlight it again so you know what I messed up. So then this 111 and this 111 changes to both be 108. And then I'm just going to erase the bottom line. So I take 108, looking back at my bottom line, solving that, minus 188 gives me -80. So I have 54y minus 94y is -80. 54 minus 94 gives me -40. So -40y is -80. And y will be 2. All right, plugging back in to get my x, I'm going to plug into the x equals equation all the way up here. So I get x equals 94 minus 47 times 2. So 94 minus 47 times 2 gives me 0. So x is 0. Very exciting answer. And it asks for x and y, and there are x and y. All right, that's all.